Your battery is your van's fuel tank. Everything else connects to it. Solar fills it up during the day, your alternator tops it up while you're driving. And everything in your van draws from it, your fridge, lights, phone, all of it. Now look, there are two main types, AGM and lithium. And I'm going to be straight with you. For Australian van builds, lithium wins, hands down. Here's why that matters specifically for us. With AGM, you can only safely use, let's say, 50% of its capacity or you damage it. So 100 amp hour AGM actually gives you 50 usable amp hours. With lithium, you can use 100%. Same size battery basically, double the useful power. And in an Australian heat, lithium handles it way better than AGM. It's more expensive up front, yeah, but it's worth it for Australian conditions, absolutely. Right, solar panels. This is power comes in. Free energy straight from the Australian sun, hitting your roof and turning it into electricity. Now, most people think you just slap panels on the roof and wire them straight to the battery. Don't do that, seriously. The voltage coming off a panel is too high and too unstable. You damage the battery fast. You need a middleman between your panels and your battery. We'll get to that in a second, but first, you have two main types of panels. You have fixed rigid panels mounted to your roof, or portable solar blankets you lay out at your campsite. For most Australian van builds, you want to be looking at fixed roof panels. They're always working whether you're at a campsite or parked on the street. Zero setup. Just free power coming in all day. And when you're buying panels, look for monocrystalline. It's the most efficient type. Imagine your solar panels are a water source and your battery is a tank. Without anything in between, you get too much pressure and the tank gets damaged. The MPPT controller is like a smart tap that controls exactly how much flows in and at what rate. MPPT stands for maximum power point tracking. It sounds complicated, it's not. It just means it's constantly adjusting to squeeze maximum power out of your panels regardless of what the sun's doing. The alternative is a PWM controller. It's cheaper, but you lose up to 30% of your solar output. So don't buy cheap here. Always MPPT. 3 brands worth knowing in Australia. Victron is a premium option. It's excellent. Renogy, it's great value. And you got EPV, it's a budget friendly and it works well for basic setups. So every time you're driving down the highway, you could be topping up your house battery instead of relying only on the sun. That's what a DC to DC charger does. It connects your starter battery, the one that runs the engine, to your house battery. The alternator generates power while you drive. DC to DC charger feeds that into your house battery. Now here's something that genuinely catches a lot of Australian van builders off guard. And I want you to pay attention to this one. Most modern vans have what's called a smart alternator. Old vehicles had simple alternators that charge at a constant voltage. Smart alternators vary their output to save fuel. And the problem is, your house battery barely charges from a smart alternator without a DC to DC charger. So you're driving for 3 hours thinking you're charging your battery, you're barely adding anything. Next up is shore power. This is another way power comes in. This is your external plug-in, like when you connect to mains power. You install a waterproof inlet on the outside of your van, and inside that runs to a smart charger that fills your batteries up fast. Way faster than solar can on most days. Now, shore power is optional. Plenty of van builders never install it. If you're planning mostly free camping in the bush, you might genuinely never need it. But if you want to quickly charge up at home between trips or plug in at a caravan park, it's a solid addition. One important thing for Australian builds specifically is making sure any shore power components are rated for our 240 volt standard. Some of the cheaper units sold online are set up for American 110 volt power. They won't work here and can destroy your gear. Now let's talk about power going out. Your battery stores power at 12 volts DC, but your laptop, your kettle, your induction cooktop, they all need 240 volt AC power. Same stuff that comes out of your wall at home. An inverter takes your 12 volt battery power and converts it into 240 volt household power so you can run those things. Now you have two types. You have pure sine wave and modified sine wave. Don't buy modified sine wave. I know it's cheaper, but it produces choppy, unstable power that over time just kills your sensitive electronics. Your laptop charges slower, it runs hotter, and it won't last as long. Pure sine wave is clean power. It's identical to what comes out of your wall at home. It's safe for everything, and for Australian van builds, always want to go with pure sine wave, without exception. The price difference isn't worth the risk to your gear. Not everything needs 240 volts though. In fact, your most important van gear, your fridge, your lights, your water pump, your USB chargers and your roof fan, all of these run directly on 12 volt DC power. These connect through a central 12 volt fuse box. Think of it exactly like the switchboard in your house. Every circuit gets its own fuse. And here's why that matters. If something goes wrong on one circuit, like a short circuit, that fuse blows and protects everything else. Without fuses, a fault can overheat, wiring hidden inside your walls and start a fire. Every positive wire running to a 12 volt appliance needs a fuse. Not most of them, all of them. The fuse box keeps everything organized, safe, and easy to troubleshoot. Sticking all those cables directly onto your battery terminals is messy, it's dangerous, and it's a nightmare to troubleshoot. Instead, you connect everything to heavy-duty metal bus bars. One positive, one negative. Then a single heavy cable runs from each bus bar to your battery. It's clean, organized, and safe. You also need a battery monitor. This is your fuel gauge. A small device called a shunt is installed on your negative cable to measure every single amp going in and out. Your display tells you exactly what percentage your battery is at, how many amps are flowing in from your solar, how many are going out, and roughly how long until you're flat. Without a battery monitor, you're guessing. With one, you always know exactly what your system's doing. To see how it works in the real world, let's look at a normal day. Through the morning you make breakfast, you charge your phone, maybe work from your laptop. Solar keeps pace with what you're using and keeps topping up the battery. In the afternoon, you drive to your next campsite. While you're cruising down the highway, your DC to DC charger kicks in. Your alternator is running, it's topping up the battery. There's more power coming in. You arrive at your campsite, your battery is healthy. That evening your lights come on, your water pump runs when you use the sink, and your battery powers everything comfortably throughout the night. The next morning the sun comes up and it starts again. Power comes in all day from multiple sources. It gets stored in the battery, it goes out to power your life. That's the system working exactly as designed. But here's the secret. You don't necessarily need every single component we just talked about. The core system is just a battery, a charging source, and fuses. Everything else depends entirely on how you travel. So if you're planning mostly weekend trips with the van plugged in at home between uses, you might not need solar at all. All your appliances run on 12 volts and you don't need to charge a laptop, you might never need an inverter. If you're planning mostly free camping away from powered sites, shore power probably isn't worth the installation cost. The important thing is understanding what each component actually does before deciding whether you need it. You want to build a system that suits how you actually travel, not the system that looks impressive on paper. I mean, you can always add components later down the track. Don't buy components because someone in a Facebook group said, I've got a 200 amp hour battery and 300 watts of solar and it's perfect. Their setup might be completely different to what you actually need. Here's what you want to do instead. You want to calculate how much power you personally use every day. How many lights and for how long each night. Will you run a fridge? Do you need to charge a laptop? Do you need to run a coffee machine in the morning? Write all that down. You then want to find the wattage of each item and work out your daily amp hour consumption. That single number, your daily power usage, tells you exactly what size battery you need, how much solar to recharge it, and what inverter capacity you need. You want to calculate first and buy second, never the other way around. Let's talk about why standard sizing guides fail down under. Solar panels are rated at 25 degrees Celsius. In an Australian summer, your roof panels can easily hit 60 to 70 degrees. For every degree above 25, you lose roughly 0.5% of output. So that 300 watt panel might only be putting out 240 watts on a hot afternoon. That's why overseas sizing guides don't quite work for us. They're built around moderate climates. Extreme heat also causes AGM batteries to degrade significantly faster, which is another strong reason to choose lithium for Australian builds. Even inverters have thermal protection that will cut them out if they overheat. You want to mount yours somewhere with good airflow, not in a sealed box. The simple Australian rule: whatever the global guides say, add a buffer. Our conditions are much harder on components. While we're talking about harsh conditions, let's cover the 4 biggest mistakes that will ruin your system, or worse. First, undersized cables. If a wire is too thin for the current passing through it, it resists the flow. That resistance creates heat, which melts the insulation. Melted insulation inside a wall you can't see is exactly how electrical fires start. You always want to size your cable for both the current draw and the length of the cable run. Second, skipping fuses. Without a fuse on a circuit, a fault has zero protection. Current flows unchecked, wires overheat, and things catch fire. Fuse every single positive line, non-negotiable. Third, mixing battery types. Never put an old battery and a new one in the same bank, and never mix AGM and lithium. One will drain the other and both will fail early. Finally, modified sine wave inverters. We mentioned it, but it's worth repeating. Don't do it. Pure sine wave only. If you're wondering where to start, here is the exact purchasing order that makes sense. Step 1. Start with your battery. Its size determines everything else. How much solar you need to charge it and what size inverter you can run. Size everything around the battery. Step 2. Fuses and wiring. Safety comes first, so map these out early. Step 3. Your MPPT charge controller. You want to pick this before your panels because its specs determine what panels are compatible. Step 4. Solar panels sized to match your controller. Step 5. Your DC to DC charger for driving charge. Step 6. Your inverter, only if you actually need 240 volt power. Step 7. Shore power, completely optional. You can add it whenever you want. And finally, a battery monitor. Technically optional, but genuinely one of the most useful things in the entire system. You don't have to buy everything at once. Start with steps 1 through 4 and you've got a fully functional solar powered system. If you want a bulletproof, reliable recommendation for a standard setup, here's what I call the Aussie gold standard for a solo travel or couple. You're looking at a 100 to 200 amp hour lithium battery. Lithium handles out heat better, gives you full usable capacity, and it lasts years longer. You want to pair that with a minimum of 300 watts of solar on the roof to give you a solid efficiency buffer in summer. You then want to use a 30 amp MPPT charge controller. Victron if the budget allows, Renogy for great value. Then you want to add a 30 amp DC to DC charger, which is essential for modern smart alternators. You then want to throw in a 1000 watt pure sine wave inverter for laptops, camera gear and small appliances, and finish it with a smart battery monitor. This exact setup will comfortably power a 12 volt compressor fridge, LED lighting, your water pump and your devices indefinitely with decent Australian sun. If you only take one thing away from this video, make it this simple 3-step rule. First, power comes in from your solar, your driving or shore power. Second, it gets stored in your battery bank, which is the beating heart of your entire van. And third, it goes out safely through your fuses or your inverter. But remember the golden rule of van building. You want to calculate your power usage first and buy your components second. Do that and you'll build a system that never lets you down in the Aussie outback. And there you go, the complete campervan electrical system made simple. Power comes in from your solar, your alternator while you drive, or shore power, mains power. Gets stored in your battery bank, goes out to run everything in your van. You want to make sure you calculate your daily power usage before you buy a single component. That number drives every decision. Subscribe to Outland Systems for more Australian van build content every week. And drop a comment below. What's the one part of van electrics that's still confusing you? I read every comment and I'll see you in the next one.